This is for section 11.3, learning about normal distribution. Normal distribution, modeled by a bell-shaped curve, is a symmetric about the mean. When you look at your graph, you see that the x-bar is here in the middle. The normal distribution with a mean of x-bar and a standard deviation of sigma has these properties. When you look at your bell-shaped curve and you put your average down the center, we're going to look at values that are 1 standard deviation greater than the average, 2 standard deviations greater, and 3 standard deviations greater. We can also go less than. So if this is truly normally distributed, then 1 standard deviation above and below is going to have 68% of the data. About 68% of the area lies within 1 standard deviation of the mean. About 95% of the data lies within 2 standard deviations, and 99.7% lies within 3 standard deviations of the mean. That's illustrated here by this figure. The total area underneath here we would be considered 1. Now, it's symmetric about the mean, therefore both parts are going to have the same amount within each. So 34% of the data should be within 1 standard deviation above. 34 should be below, so we call that 68 within 1 standard deviation. When those words are used, within 1 standard deviation, that's referring to above and below. And we can do the calculations for each one of these about how this is 13.5, this is 2.35, and this is 0.15. This is 68 in the middle. If we look at 2 standard deviations of the mean, we would take the 95, you would subtract out the center portion, so you're left with just that on the sides. So we have 27. Now if 27 is in this portion and this portion, we divide that by 2, and that's where we get our 13.5 with between the first standard deviation and the second standard deviation on both sides. So just as the graph over here illustrated the 13.5, it's calculations like that that help us indicate. So let's look at how we can use this. A normal distribution has a mean of x and a standard deviation of sigma. For a randomly selected x value, find the probability that some number, some value, x, is less than or equal to 3 standard deviations from the mean. Well, if you take a look at your value, your bell curve, this is your average, this is 1 standard deviation above, this is 2 standard deviations above, this is 3 standard deviations above. Okay, just like it was illustrated here in the graph, 3 standard deviations above. We're looking at all the data to the left of that. So we want to know what's the probability that you're going to pick a value inside there. In other words, you're not going to pick a value that is greater than that. Well, a lot of it's shaded, so it's a really high probability. You could say the 2.35, the 13.5, the 34. On this side has 34, the 13.5, the 2.35, and the 0.15. You could add that all up, and you would get 0.9985. That would be your probability that you would pick a value less than 3 standard deviations above the mean. Another way you could look at it is the value you're not interested in. You're not interested in what is greater than 3 standard deviations. Coming over here to the other figure, we see that above 3 standard deviations is 0.15. That's the part we don't want. So another way we can calculate this is to say 1 minus 0.0015, which gives us 0.9985. So either way you look at that, that would be your answer. For part B, what's the probability that we are greater than 2 standard deviations below the mean and 1 standard deviation above the mean? Well, I'd suggest making your bell-shaped curve, put in your average. Right now we don't have numbers for those averages, we're just representing it as X bar. We're going to go 2 standard deviations down, so this one here is X bar minus 2 standard deviations. This one would be 1 down. This one would be 1 up. So if we want the values in between that, then we're going to say that this was 34, this was 34, this was 13.5. We're going to add those together. We write it as the percentages as a decimal when we're looking for probability. We come up with 0.815. It wouldn't be necessarily easier to do the subtraction from 1. To look at all the values we don't want would be more difficult than just adding up what we do have. Okay. Example number 2. Math scores of the 2004 SAT exam are normally distributed. This word normally distributed indicates that we'll be using this bell-shaped curve. It's normally distributed with a mean of 518 and a standard deviation of 114. Sketch a picture and answer the following questions. About what percent of the test takers have scores between 518 and 746? Well, we'll come to our bell-shaped curve. We now have a value for our average. Our X bar is 518. 1 standard deviation above the mean. That's X bar plus 1 standard deviation. That is 632. Another standard deviation plus 2 is going to be 114 more. So that calculates out to 746. So what's the probability? Or here they're just asking for what's the percent. About what percent of the test takers have scores between this? So we're looking for values between there. This was our 34. This was our 13.5. So 34% plus 13.5% give us a 47.5%. Here they ask for percent, so we gave values in percent. When we do probability, we're looking for values between 0 and 1. About what percent of the test takers have scores less than 404? So we'll make our bell-shaped curve. Put the average in the middle, which is your 518. We're going to go 114 less, which is 404. We want to know what percent is less than that. So we're looking for the values down here. Everything above the average is 50%. Between one standard deviation and the average is 34. So here we have a 13.5. And here we would have a 2.35. And down here we would have a 0.15. So we could add up our percentages that way. 0.15%, 2.35%, and 13.5%. And we would get our 16% would land less than 404. Or perhaps you would think it was easier if we took 100% and subtracted the values we're not interested in, which was the 34 and the 50. Less numbers, not as messy as those. So here we get 1 minus 84, which is also 16%. Either way you look at that, the amount of test takers below 404 is 16%.